All right, so we saw quadrant 1 yesterday of the unit circle. Today we're going to look at how to build the rest of this thing. So real quick, I would encourage you to fill this out. This is kind of the first thing. So remember, we have our parentheses. We should know that that's 1, 0. This is 0, 1. And then I'm going to go through and do 1, 2, 3, 1, 2, 3, square root, square root, square root, square root, over 2, over 2, over 2, over 2, over 2, over 2. This is 90 degrees and pi over 2. This is 60 degrees and pi over 3. This is 45 degrees and pi over 4. And this is 30 degrees and pi over 6. This is 0, 360, and 2 pi. Okay, so we should have that. All right, now I want you to, I'm going to set my timer. If you're in class, I'm going to set my timer for 5 minutes. And I would like you guys to try to fill in the rest of the unit circle in the other quadrants with the ordered pairs at least. You don't have to, and the degrees. We'll talk about the radians angles in a little bit, but see if you guys can pause the video and figure out what the ordered pairs are. Think about it in terms of reference angles and the triangles, and use the triangles that you cut out and just flip them over the y-axis. Those dimensions are all on there for the triangles. So remember, you just have to pay attention to the signs. What are the signs for x and y in each one of those quadrants? Okay, so if you did get stuck, hold on, If you are in class, I did want to say I will go over this, blah, blah, blah in a moment, but I'm not going to spend a lot of time on this in class, so if you are watching this again, you can kind of hear this again and pause the video. But anyways, so let's talk about how to fill in this. We talked about quadrant 1 already. Now, quadrant 2, or actually all the way around, the ordered pairs, we're going to start off by looking at the horizontal distance between, like here, those should be the same, right? So that's square roots of 3 over 2 on the right triangle, and it should be the same on the triangle on the left. The only difference is in quadrant 2, the x is negative. Same thing in quadrant 3. That's the same x value difference. And same thing in quadrant 4. So all of these should have a distance of square roots of 3 over 2, but we just need to think about what is x positive or negative in that specific quadrant. Same thing with the y value. That's gone up 1/2 everywhere around those. We can apply this concept everywhere. So I couldn't fit this in those parentheses, so I wrote them to the outside, but we can really just look at the corresponding, going back to their specific reference angle at 30 degrees. 30 degrees away from the x-axis on both sides, so 180, 30 degrees minus that, 30 degrees greater than that, and then the same thing, 30 degrees less than 360 will give us those, and we should be able to write those out. We can do the same thing for the other ones as well, so I'm not going to spend a whole lot of time on this, but just kind of filling this out here. Now, let's label the angles around here as well. So this should be on our big unit circle that we have, our nice and pretty final draft one. Hopefully you didn't make a lot of mistakes on that, because I want it to be, it would be better if it was, nice and clean. But if we notice the pattern, we go from 0, and then our first line's at 30, 15, 60, and 90. So we go up 30, then we go up 15, then we go up another 15, then we go up 30. So that pattern works like this, like 30, like 0 plus 30 plus 15 plus 15 plus 30. So if I were to continue starting at 90 degrees, I would get 120, 135, 150, and then 180. And then continuing around the pattern, I get this, right? And so on and so forth. Now, let's look at the radians real quick. So pi over 6 is our first line, our smallest angle that we have on the unit circle. And this would be considered our reference angle. Our reference angles are between 0 and pi over 2. So this would fit. Now, in quadrant 2, I'm going to kind of give you a hint for these, they're all going to have the same denominator. Like the 30 degree or the pi over 6 reference angle, all the purple lines that I'm going to have are all going to be over 6. The numerator is going to be the only thing that changes. And you can think about it like this. In quadrant 2, 5 pi over 6 is almost 1, right? Because if that was 6 pi over 6, that would be 1. 6 over 6 is just 1, right? So in quadrant 2, all of our reference angles, or all of our radian angles, are going to be almost 1 with respect to their denominator. Quadrant 3, it's going to be more than 1, like 1 more than 1, as a matter of fact. You can also think more specifically on quadrant 2, you can say 1 less than 1. So, and we're kind of ignoring the pi when we say that. Like 5 over 6 is 1 less than 1, because if it was 6 over 6, that would be 1, right? 7 over 6 is 1 more than 1. If it was 6 over 6, it would be 1, right? And then quadrant 4 is almost 2. So we're almost to 12 over 6 is 2, right? We're almost there. So we can repeat that for all of these. The reference angle pi over 4, what would almost 1 be if the denominator has to be 4 for all of my pi over 4 reference angles? Well, 3 pi over 4 would be that one. Then more than 1 would be 1 more than 1, so 5 pi over 4. Almost 2, so 7 pi over 4 for that one. And then we do the same thing. So pi over 3, almost 1 would be 2 pi over 3. More than 1 would be 4 pi over 3. And almost 2 would be 5 pi over 3. So it works like that. Another way you can do this too, to kind of set this up, is you can say, well, they're all going in like pi over 6. Skipping the pi over 4 ones, this is just 2 pi over 6. 3 pi over 6. Oops, 4 pi over 6. 5 pi over 6. 6 pi over 6. And we can do that all the way around, starting with pi over 6. And notice this just simplifies to pi over 3. That simplifies to pi over 2, so on and so forth. So that's kind of another pattern that you can think about too. Starting with pi over 6, you got to skip the 45 degree ones because those don't fit, obviously. But that's a way that you can do that as well. Okay, so here's our full, complete unit circle. All right, let's look at the entire unit circle. They're made up of only these numbers on the ordered pairs. See? The ordered pairs only have those numbers, 0, 1. Now, they're positive and negative versions of those, which we'll talk about here in a minute. So you need to memorize quadrant 1. And then when we are in quadrants 2 to 4, we need to consider the following. That the given angle and the reference angle will have the same ordered pairs but different signs. So depending on the quadrant of the given angle will depend on whether the x and y values are positive or negative. Furthermore, we need to know that sine is y and cosine is x and tangent is y over x. So we're going to look at this mnemonic device to kind of help us. So there's 2 things that every single day you should spend the first 30 seconds doing, and that's sketching quadrant 1 and sketching what we're about to do. So signs and trig functions. So in quadrant 1, recall that x and y are both positive. So sine of theta equals y, that's positive. Cosine of theta is equal to x, that's positive. Tangent, if both y and x are positive, then y divided by x is positive. So everything is positive. All trig functions are positive in quadrant 1. So I'm going to say this is all. Now let's look at quadrant 2. So if sine is y, sine is positive in quadrant 2. Or sorry, y is positive. X is negative though, and that's cosine. And if we have a positive divided by a negative, that means tangent is going to be negative. So here, if we're looking at the, this is a positive sine chart, by the way. So in quadrant 1, all of them were positive. Here in quadrant 2, the only one positive is sine. So we're going to say sine is positive in quadrant 2. And we're going to think about it like this. This is our mnemonic device. All students. So A for all, S for sine, and then let's look at quadrant 3. X and Y are both negative. So if Y is sine, that's negative. Cosine is X, that's negative. If I divided a negative by a negative, that's a positive. So tangent's the only thing positive in quadrant 3. And that's where this comes from. All students take. So let's look at the last one, quadrant 4. X is positive, Y is negative. So a negative divided by a positive is negative. So here in quadrant 4, cosine is the only positive trig function. So if it's positive, we're going to help remember this by saying calculus. So all students take calculus, or ASTC, however you want to think about that. So I would do this in addition to quadrant 1 on your test, just to kind of help you kind of figure out what it is we're doing. All right, so if we're sitting in class, I would have you fill this out real quick and see if you can do that, get practice at filling out quadrant 1. I'm not going to do it again, but now we're going to look at other areas of the unit circle, and I'm going to explain why we don't care a whole lot about the other side of the other parts other than quadrant 1, because we're going to trace everything back to quadrant 1. But we do need to understand the sign, positive or negative, for X and Y at 120 degrees based off of what quadrant that's in. So first and foremost, I'm going to figure out what quadrant 120 degrees is in, and I should know that that is in quadrant 2. So what is my reference angle? If I'm in quadrant 2, how far away from 180 degrees am I? Well, I'm 60 degrees from 180. So that's what I care about. And if I already have this marked down in quadrant 1, then I can look and I can say, what is sine? Sine is y. I already have 60 degree marked. That says square roots of 3 over 2. Great. That should say square roots of 3 over 2 at 60 degrees for the y value. But not quite. So we have two parts, right? We have this thing that we should have had, right? And the y value is square roots of 3 over 2 at 60 degrees. But I also have this sine thing. So now I need to think about, well, what quadrant am I actually in? I'm in quadrant 2. Because that's at 120 degrees. So sine is positive there. And this is talking about sine, so I'm good. So it is just square roots of 3 over 2. It's going to be the same coordinate, but I just need to think about what the sign is for that. And it's going to be positive because sine's the only thing positive in quadrant 2. Okay, cosine, 225 degrees. That should be in quadrant 3. Sometimes when I'm going through these, I will go ahead and put a negative in my answer so I don't forget. And then I figure out what is my reference angle. So how far away from 180 degrees am I? I should be 45 degrees. That's the easy one, the square roots of 2 over 2. Both sine and cosine are the exact same thing. So this is square roots of 2 over 2, but cosine is negative in quadrant 3. So is sine. So I'm going to make that negative. And once again, we can take a little bit load off of our brain by writing those sine charts and the quadrant 1 down. Tangent of 330 degrees should be almost a full way around in quadrant 4. I am 30 degrees away from the x-axis. I do know that all students take calculus, so calculus is the only thing, cosine is the only thing positive in quadrant 4. So I know that my answer should be negative. So if you want to go ahead and write a negative up there, that's fine. We can get that out of the way. So this is 30 degrees. So if I'm doing this is how I do it in my head. I know y'all can't see, but I go from the top and I'm like 1, 2, 3 for x, and then 1. I'm right there. It's that very first one. So I know that that is 1/2. That's my y value, and then the square roots of 3 over 2 is my x. So I'm going to do 1/2 divided by square roots of 3 over 2, which is this. Those are going to cancel and give me that. Rationalize my denominator, and I get that. So I know that this answer for tangent of 330 degrees is negative square roots of 3 over 3. So you are going to have to tell me this stuff without using a calculator, by the way. You will not have a calculator on this. All right, tangent of 5 pi over 6. So what is my reference angle? What quadrant am I in? Well, I'm almost to 1. So almost to 1 is in the second quadrant, quadrant 2. I do know that tangent is negative because sine is the only thing positive in quadrant 2. My reference angle is always ignoring the numerator and just looking at the pi over 6. So my reference angle is just pi over 6. So now I'm going to go back to my quadrant 1, look at pi over 6. That's the very first line that we have, right? And it's 1, 2, 3, 1, so 1/2 over square root of 3 over 2. Right there, 1/2 over square root of 3 over 2. And is this the same one we just got done doing? No. So this should be square root of 3 over 3, and then what quadrant am I in? 2. So that should be negative. Negative square root of 3 over 2. 3 over 3, sorry. Square root of 3 over 3. So in quadrant 2, sine's the only thing that's positive. So I have negative square root of 3 over 3. All right, 5 pi over 3. What is our reference angle? Our reference angle should just be pi over 3. And we are almost 2, right? 6 divided by 3 is 2. This is 1 less than that. So this is almost 2. So I'm going to be in quadrant 4, where all students take calculus. So sine is negative in quadrant 4. So I can go ahead and write a negative sign if I want. My reference angle is just pi over 3. And so what is that? That's the last line before the 90-degree angle. So 1, 2, 3, top to bottom, 1, 2, 3 for the x, but this is y, so I'm going to go to the other side. 1, 2, 3, that should be square root of 3 over 2, but it should be negative. All right, 7 pi over 6. That is more than 1. 1 more than 1, so that should be in quadrant 3. My answer should be negative. And my reference angle is pi over 6. And once again, I'm getting that from just like with the radians, you can just ignore that numerator, the 7 there, and what's left is your angle. So that is my very first line. That is the x value. All right, if I count down 1, 2, 3, that's my 3. You should be familiar, hopefully, with the square roots of 3 over 2 at that mark. So that should be square roots of 3 over 2, but we are in quadrant 3. So all students take. Tangent's the only thing positive in quadrant 3. So cosine is negative, so it's going to be negative square roots of 3 over 2. All right, we got a negative angle. Let's go ahead and make that positive. You remember coterminal angles. We can add 360 degrees to this and forget about the negative. So this is the cosine of 135 degrees. What quadrant is 135 degrees in? That's in quadrant 2. All students, sine is the only thing positive in quadrant 2. So I can go ahead and make my answer negative if I want right now. I'll go ahead and put a negative sign in there. My reference angle, how far is 135 degrees from 180 degrees? That is 45 degrees. Those are my nice ones that I like because I know that they're square roots of 2 over 2 for both sine and cosine. Now I just need to remember I'm dealing with cosine in quadrant 2. Cosine's negative in quadrant 2, so this is going to be negative square roots of 2 over 2. Sine's the only thing positive. My problem says cosine. So that's negative square roots of 2 over 2. Same thing here. Let's get the positive coterminal angle. I'm going to add 2 pi to this. Make that 11 pi over 6. Oh, that is almost 2. That is in quadrant 4. My reference angle is pi over 6. All students take calculus. C stands for cosine. So in quadrant 4, cosine's the only thing positive, so tangent is negative. Pi over 6 is our reference angle. That's our first line. So I'm going to count down 1, 2, 3 for my x's, and then count up 1, 2, 3 for my y's. So 1, 2, 3 down, and then 1. That 1 is my 1/2, and then divide that by square root of 3 over 2. And once I do that, and I know that that's negative, that should simplify to negative square roots of 3 over 3. All right, guys, I know it's a lot, but you can do it. You need to get the practice on this and ask questions as you have them. Good luck.